So today we're going to talk a little bit about this kind of joystick controller for the Arduino, and we're going to implement that together with the NeoPixels at some time. So this is going to be a 3-part video as well for this is how to hook it up and wire it, everything. And the next video is going to be a little bit more about how do we map it onto the NeoPixels, and the last video is going to be how do we make a game out of it. So the basic about this controller is that it has these 5 connectors right here. So here on the side, it has these 5 connectors, being ground, 5 volts, and then this VRX and VRY, and that's the analog output for the controller. So that's like what can see how this is positioned. So it's something like this is the Y-axis and this is the X-axis. I don't know if that's true, but something like that. And then in the bottom there is SW, being the switch function, being because it can click. So I'm just going to hook this up to my Arduino board, and for that I have these jumper cables here in the back. A good thing, so I'm going to hook it up so that I can remember the colors kind of. So I'm going to take brown as being a close color to black, what we usually use as the ground wire, and the rest of these wires are fine. I can just hook them up like this. Okay, so I only have female connectors here, so I just took some male connectors and connected them together like this, and the colors are kind of matching, but not really. See, I have 2 yellows over here. It doesn't really matter for me. I'll just find my 5 volt and my ground connection. That's the 2 easiest ones, so that will be red and brown here, and that goes into these 2. So brown is green, and that being ground. So I'm going to take that and connect it into my Arduino here, and connect the other one to 5 volts. Okay, and the other 2 connectors here are the analog inputs that's going to have a value ranging from 0 to 5 volts, and that's going to be about how this one is positioned. It's going to vary about that. But this is what we call an analog input, because it's going to vary from how I position this, give a value between 0 and 5. So that's what we call an analog signal. We're going to put that into the analog inputs over here, not to be confused with digital inputs over here. So I'm going to connect mine into A0 and A1 like that. And I don't know which one is X and Y yet. It doesn't really matter for me. I can always swap the pins or just change it in the code. So that's the basic wiring. So let's just make a simple program that is able to read out the values when I change this into the serial monitor on the computer. Okay. So let's take a look at the code here. So this is the code that we're going to have to do today. I'm going to put this in a link below so you can always download it. So what I've done here is I have in the top defined 2 pin outs, and that's where my pin joystick is connected to. I connected the X to A0 and the Y to A1. I actually don't know if that's true, but I can swap them if I want to. I can just make this one A1 and this one A0 if I want to. It doesn't really matter. And then I'm going to have these input here, so this pin mode, and that's for initializing the pins as being inputs, because you can also use them as outputs. So to tell the microcontroller which one you're using, you have to tell it that it's an input. And then we have this serial begin, and this right here is what we call the baud rate, and that's how fast the computer and the Arduino is communicating. And if I open up the serial monitor here, so down here is the baud rate I can set it for, and you just have to make sure that these 2 are set to the same thing. So I'm going to set mine to the 9600, and you're going to see right now that I'm going to get some things that doesn't make any sense. If I restart my Arduino, it's going to give me some more nonsense, because my previous example hasn't been using this baud rate. But just remember that these 2 should match. Pretty common ones are either 9600 or 115200, like that. That's also a pretty common communication baud rate, but you can use anything you like just as long as they match. And then I like doing this kind of line here, where right after I just initialize the serial, I am writing Arduino booted. So that just always confirms me that, okay, I have communication with my Arduino and everything is working just fine. Okay, and then I'm gonna come to this part in a bit. So I'm gonna change some of this code. So it just is the simplest form that I can get it. And we're gonna come back to this mapping. Okay, so what happens here is I'm initializing two variables, xpos and ypos, and I'm gonna do this as an analog read, and I'm gonna use the analog read. I have to usually write something like A0 in here, but I already did that up here, so I'm just gonna use that name down here. So I have only to change that one time in my code if I, like in the top, if I ever get to have to swap them anything later. So I'm initializing the two things and I'm saving the input into this X position, and then I'm writing just a string of letters here. So this is just for me to understand it. So it's gonna write X position semicolon, and there is also a space in here. Then I'm gonna write the X position, and what you should notice here is that this one has an ln command after the print, and that means that it's gonna hit an enter symbol. And then I'm going to write the Y position, and then the actual Y position, and X. This will make sense if I upload this. You'll see that it gives a little bit more sense to it. So what you're going to see here is it's going to write X position, semicolon, a space, and then the value. And it's going to keep doing these two and do them every 500 milliseconds because that's my delay function, just to make sure that I can actually read what's going on here. So what we see here is that they are about 500. That's because they're in the middle right now. So if I take this meter and I push it all the way to one side, you're going to see that one value is going to be 0. If I push it to the opposite side, it's going to be 1023. So that's because we're having what we call a 10-bit ADC converter, so an analog to digital converter. And that's going to put the values from from the 0 volt to 5 volts into values between 0 and 1023. The same thing goes if I push it up, it's going to read 0. If I push it down, it's going to read 1023. And of course, this is very, like the X and Y axis is very dependent on which way I hold the joystick here. If I hold it like this, it's going to be different. So that's all about how you mount your controller, how you're going to map this out. But what we want is that we want to have this on our display here. So what I'm thinking is I want the middle one to light up when the controller is in the middle, and then let it be controlled. So when I do the upper left, it's going to go up here and down right and so forth. So I can actually control a dot around in here. That's what I'm planning to do. So we're going to talk a little bit about a mapping function now. And inside the Arduino, that was the original code in here. I'm just gonna Control C until I get it back. So I have this map function here that I'm using. So I'm using a new variable called xMapped. Actually, like that. Just have to change it down here. So here I have the xMapped value, and this is the function here. So the map function is able to take a value that it's going to expect to be from 0 to 1023 and remap it to a value I want to be between 0 and 4. And that's of course because the display here again, we start from 0, so this is pixel 0, 0, and this being 0, 4. So that's how I want it mapped together. So I just do that for both functions, and I save that value into the yMapped, and then I change the print function here to be xMapped and yMapped instead. So now this one should write X position and Y position and a number between 0 and 4. So as you see here, it's booted. It's going to tell me it's in position number 1. That's actually not correct. I found giving this a little bit of breathing room. So like example, writing 1000 in here instead of all the way to the exact values is giving me a little bit better responsiveness, because I want it to be number 2. Again, because of the pixels here, I want it to be in the middle, and that's going to be 0, 1, 2, 0, 1, 2. So that's going to be this pixel. Okay, so I want it to do like that. And when I control it to one side, it's going to read 0. If I control it up, it's going to be 0, 0. So this is how I want it to be mapped. Okay, so in the next video, we're going to talk about how do we implement that color and the small dot into the NeoPixel matrix here, and how we can control it. See ya.